Very good morning, children. In the last classes we have discussed about the ionization energy. So on the basis of that, the energy, what is ionization energy? The energy required to remove an electron from outermost orbit or shell of a neutral gaseous atom. So the energy required to remove an electron from outermost orbit or shell of a neutral gaseous atom is called ionization energy. And these also two types, children. What is two types? What are those two types? Means here the ionization energy, the energy required to remove one first electron from an atom. So first ionization energy, that is called as first ionization energy. The energy required to remove an electron from outermost orbital is called as ionization energy. And again after positive ion, unipositive ion, again we have to remove one more electron, means that is second ionization energy. So second ionization energy of an element is higher than its first ionization energy, because the first ionization energy is more. Why? Because the energy required to remove electron from unipositive ion is very much high, because it is very stable. Unipositive ion is stable, and positive charge binds electrons more strongly. Positive charge binds electrons more strongly. So due to that, the second ionization energy is always higher than the first ionization energy. So in this manner you have to understand about ionization energy. And in the last class I already explained you about nuclear charge. If nuclear charge more, then the ionization energy will also more, because here see one example I want to tell you: sodium and chlorine. So chlorine atom has more ionization energy than sodium. Why? Because of that nuclear charge is high for chlorine than sodium. So in that manner ionization energy is more for chlorine. So we have to understand that one. Next one is screening effect or shielding effect. We can also call screening effect or shielding effect also we can call that one. And this is called, why? Because here the outermost shell within the electrons, shells with electrons between the nucleus and the valence shell, more shells are there, means that shells behaves like screens. Here see, if there are more shells existing between the outermost shell and the nucleus, so these more shells will act as screens. So due to that screens, they are becoming dummy or transparent. So due to that, ionization energy will become as less. More screens means that is screening effect. If more screens, that means dummy shells. More shells are existing between the valence shell and the nucleus. That shells behaves like screens. So that effect is called as screening effect. Here the ionization energy will become as very less. So next one is penetration power of the orbitals. Penetration power means piercing power towards the nucleus. So actually the s orbital is nearer to the nucleus. That's why s orbitals having more piercing power than p orbitals, than d, than f. So in that manner 4s is tightly bonded, which is nearer to the nucleus. The piercing power is more because of only 2 electrons. So to remove electron from 4s is tough than remove electron from 4f. That is, it is easy to remove electron from 4f suborbital than 4s orbital. So in that manner ionization energy is less for 2p orbital than 2s. 2s orbitals are having more ionization energy than 2p orbitals. Stable configuration. This also I told you in the last class only. It is easy to remove one electron from oxygen than nitrogen. Why? Because nitrogen has stable half-filled configuration. See, nitrogen has stable half-filled configuration. Nitrogen atomic number 7. So 1s2, 2s2, 2p3. Here 2px, 2py, 2pz orbitals are completely half-filled, exactly half-filled. So stable configuration. So that's why it is very hard to remove electron from the nitrogen than oxygen. So stable configuration. Due to the stable configuration, ionization energy will increase. And next one is atomic radius. If atomic radius more means ionization energy automatically less. If atomic radius less means ionization energy more. We can also call ionization energy as ionization potential, and the units we can write in this manner. EV atom universe are the units. And while coming to the groups, from top to bottom ionization energy decreases, and while coming to the periods left to right ionization energy increases. Remember this point. In groups ionization energy from top to bottom decreases. In periods from left to right ionization energy increases. Just understand these, children, and these are the factors affecting that ionization energy, nuclear charge, screening effect. These all are the factors: penetration power or piecing power, stable configuration, and atomic radius. Screening effect or shielding effect also you have to understand. I think you got all these points clearly. And next I want to tell about the electron affinity or electron gain enthalpy. So this means that it is defined as electron affinity means the atoms of some elements gains electrons forming ionic compounds. For example, for gaining, here it is exactly reverse to the ionization energy, children. To remove electron we need some energy, that is ionization energy, and here electron affinity is defined as to get the energy, to get the electron. So to add one electron to the atom, how much energy liberated? So that is electron affinity. To add the electron, how much energy needed? Here to remove the electron is ionization energy. To add the electron to the atom, it is electron affinity or electron gain enthalpy we are calling. So here this is also two types: first electron affinity, second electron affinity. So if we add one electron to uni-negative ion, so the element is called as second electron affinity. So if we add uni-negative, if we add one ion, not ion, if we add one electron to the neutral atom, so at that time that is first electron affinity. That energy is first electron. The energy required for adding one electron to the neutral atom is called as first electron affinity. And if we add one electron to the already uni-negative atom, that one is second electron affinity. So no elements liberation of energy when second electron is added to its uni-negative ion. That means di-negative or tri-negative ions do not form. But liberation of energy when second electron is added to its uni-negative ion only. Added to its uni-negative ion. Energy is another way, like bond formation must be given here. So here we have to give energy for bond formation, not for di-negative, tri-negative. In the case of ionization energy, we are taking like that, but here second electron affinity is for bond formation. So electron gain enthalpy values are decreasing top to bottom, and in the case of ionization energy also like that, decreasing from top to bottom. And in periods left to right, that electron affinity is increasing from left to right, increases from left to right. And metals have less electron gain enthalpy values, and alkaline earth metals are here giving sign than here metals having more electron gain enthalpy than alkali earth metals, and negative sign indicates that liberation or loss of energy, and positive sign absorption or gain of energy. So ionization energy and electron enthalpy factors are same, both are having same factors, and groups top to bottom decreases ionization energy and electron gain enthalpy, and coming to the periods left to right, this is increasing, both are increasing. And the here one question they have given in your textbook: the calculated electron gain enthalpy values for alkaline earth metals and noble gases are positive. Why? Electron gain enthalpy values for alkaline earth metals and noble gases are positive. How can you explain? When the sign will be positive, when gaining of electron, the sign will be positive. I told now, children. When it is, the sign is positive when gaining or absorption of energy. So due to the completely filled subshells, alkaline earth metals completely filled valence shells. Alkaline earth metals are completely filled. Hence energy is required to add. That means absorption of energy to gain an electron is needed. Absorption of energy is needed to gain an electron. So in that manner, noble gases and alkaline earth metals, due to the stable configuration, due to the completely filled valency shells, they need more energy. So there is a need for absorption of energy rather than liberation of energy. That's why it is called as electron affinity for that alkaline earth metals and noble gases is positive, because gain or absorption of energy is needed here rather than liberation or lost. So the energy needed, that may be liberation or absorption, for adding one electron to the neutral atom is called as electron affinity. Don't get confused. And the second question here, what they have given, the second period element F has less electron gain enthalpy than chlorine. Just explain. I told now only. Second period element F has, from periods in groups top to bottom, it is decreasing. Electron gain enthalpy is decreasing in groups top to bottom. Second period element F and third period element Cl, both are existing in same group, and Cl is having less. Why? Because top to bottom decreasing. In that manner also I explained why it is decreasing in groups. Electron gain enthalpy is decreasing in groups. Why? Top to bottom it is decreasing. Why? Why? Because electron gain enthalpy is energy change. When fluorine has less electron gain enthalpy because of less space. And while coming to the chlorine, it is having 7 outermost electrons only like fluorine, but it is having extra d orbital which accommodates more space. So it is easy to add electron. So more liberation of energy in the case of chlorine. That's why electron gain enthalpy of F is less than chlorine. In that manner you have to understand, children. Next topic is about electronegativity. So electronegativity is the ionization energy and electron gain enthalpy. Those properties are considered here in the case of electronegativity. The electronegativity of an element is defined as relative tendency of its atom to attract electrons towards itself, and when it is bonded to the atom of another element. That means electronegativity is equals to ionization energy and electron affinity. The average of the two is called as electronegativity. The average of ionization energy and electron affinity is called as electronegativity. So it is an element defined as relative tendency of its atom to attract electrons towards itself. That may be gaining or may be adding, or may be losing or may be adding. So that's why electronegativity. It is due to electronegativity is the tendency to bond formation. Tendency to bond formation. Don't get confused, children. Electronegativity is the average of ionization energy and electron affinity. And next one is metallic and non-metallic properties. So metals are generally showing less electronegativity. Metals are always showing less electronegativity than non-metals. So tendency remains as positive ions. So tendency here remains as positive ions, not negative, because they always lose electrons. So less electronegative character. So show tendency to remain positive ions only. They always shows tendency to become as positive ions. They want to lose always. Electronegativity is less. This property is often termed as electropositive character. So metals are having electropositive characters than electronegative characters. Tendency to lose electrons is called as electropositivity, and tendency to gain electrons to make bond formation is called as electronegativity, and which is the average of ionization energy and electron affinity we are taking, and both are possessing same property. And here we can understand non-metals are generally more electronegative than metals. Non-metals are more electronegative. Here see, sodium to magnesium are metals, aluminum and silicon are semi-metals or metallites, phosphorus, sulfur, chlorine are non-metals and which are possessing higher electronegativity. So that's why metals always showing electropositivity. So the losing of electrons is most possibility there for lasting of electrons there is a most possibility for the metals. Non-metallic character increases. So at that time that means metallic character decreases, then non-metallic character increases in periods in periodic table. Just observe here, metals on left side. We can observe metals on left side, non-metals on right side in the periodic table. This means that metallic character decreases while non-metallic character increases as we move along periods. Left to right, metallic character decreases left to right. As we move from left to right in periods, metallic character decreases while non-metallic character increases. Understand this one. And carbon is a non-metal, silicon and germanium are metallites. So here we find non-metals particularly at the right hand side, top of the metals. At the left and right hand side, bottom of the periodic table. So here non-metals particularly at right hand side, top and right hand side top we can observe non-metals, right hand side top, and metals at left and right hand side, bottom of the periodic table. Left and right hand side, bottom of the periodic table, left and right side of the periodic table, bottom. We can observe metals. This means metallic character increases while non-metallic character decreases in group. As we move from top to bottom, metallic character increases, non-metallic character decreases. Don't get confused. In periods, left to right. In periods left to right, metallic character decreases, non-metallic character increases. And in groups, top to bottom, metallic character increases, non-metallic character decreases. So in that manner we have to understand. So be careful. Just understand this lesson. Thank you for nice class with you.